I've worked brief introduction as research and valorization manager at ITEC since 2014. Before that, I did a PhD in the same group and was active in EdTech innovation and research projects, both at KU Leuven and at a different university in Belgium. And when Wim asked me to talk about my experience in innovation and that of my research group, of course, and how that links to EdTech, collaboration with the EdTech sector, also in close collaboration with other societal partners. Um, my idea was to share with you today our vision on innovation, because I think if you don't have a vision on innovation, you're starting on the wrong foot. And secondly, I also thought I needed to share our strategy. So I will not be talking about research in detail. This will not be a detailed technical talk. Maybe a little bit at the end of my talk, I will dig deeper into adaptive learning and personalized learning, which was also introduced by Wim. But I will mainly talk about our vision and our strategy and our model of collaboration with the industry and with other partners in the local ecosystem in Flanders and beyond that. One word about our research group before I dig deeper. So what we do and who we are, we do fundamental and applied research on personalized and adaptive digital solutions, but are actually active mostly, as Wim already said, in the domain of EdTech, so basically in the application domain of education and training. But next to that, we're also active in the fields of media and health. Whenever there's a link between the methodological part of our research group, and that will become clear a little bit later in the presentation, and the media and health sectors, whenever we have research problems that are that have the same challenges, we also collaborate with partners in media and health, for example. But today will be mostly about and will be limited to our work in education and training. We are, and that's also unique about our group, we are an interdisciplinary group. We were founded in 2007 on the basis, well, let's say on the basis of another group that had been around for quite a while. But as an interdisciplinary group, we have existed since 2007 at the Kulak campus of KU Leuven. That is in Kortrijk. That's not in Leuven, but that's actually closer to London, where we kicked the project off. It's close to the French border. And that's mainly a bachelor campus and also a PhD campus. So we have we're actually a comprehensive bachelor campus. So we offer all educational programs that are offered on the main campus of Leuven, but for bachelor students. But in a smaller setting, we have about 1,500 students, and so all the disciplines are represented, and this is also reflected in our research. So we are our group is comprised of people in educational sciences, but also in computer sciences and in language sciences. And because we are on the same campus, we are actually also in the same building, our group, we can actually forge those collaborations between those different disciplines, which is quite critical in the edtech sector. So that's the way we were founded. And the second element that's important, and that's also important for innovation about our Kortrijk campus, is that Kortrijk is also the EdTech lab of KU Leuven. So we are a smaller campus where we have smaller student groups, and we can also experiment with like new forms of technology in a smaller scale. And whenever we find that an innovation with our students, with our own university students, works, we try to scale that up to the bigger University of Leuven. So to the other campuses, and I will be talking about a couple of projects that have gone that way as well. So that's my short introduction about what we do and who we are. So I said I would be talking about innovation, but no innovation without vision and strategy. So I will first talk to you about our vision. on EdTech, and what kinds of innovations we actually envisage with our research. This is a bit of a simplified picture, but you can consider educational technology a little bit like this. So you have, on the one hand, you have learners. On the other hand, you have learning tasks. And let me pull up my pointers. That will probably be more engaging to follow. So we have the learning community, and we have the learning tasks. Um, and somewhere in between nowadays, often there is a piece of technology, a human machine interface, you could say, that mediates the learning process, that visualizes content that is often pulled from a cloud nowadays. And it allows learners to interact with the tasks, with content, but also between each other and with an expert on the side. So typical situation of EdTech nowadays, these could be tutoring systems where the focus is on interaction between learners and content. Um, these could also be platforms for collaborative learning and teaching, like Zoom is not specifically, the platform that we're using today is not specifically developed for teaching purposes, but we often use it because we have to. And but it's not the best situation often. So what we do in our research is to focus on development of new techniques that makes these kinds of experiences, learning experiences, more effective and also more engaging. Um, but a problem nowadays, often with many edtech products, and I think that the people of London have talked about this, of UCL have talked about this in previous ISPs before, is that edtech products are often not designed on the basis of sound models of learning, and even less often they are evidence-based, meaning that they have been validated in experiments that with learners and seen what kind of interventions work best for learning and engagement. So that's unfortunately often the situation nowadays. Now, what we see is that currently there are a couple of global societal challenges which make that we need to step up our game in edtech. And do better, basically, and innovate. And these two key societal drivers are, on the one hand, what I call super diverse learner audiences. And I often like to quote the sociolinguist Jan Blommaert on this, who unfortunately passed away last year. He was a Belgian sociolinguist who actually made it clear for me for the first time what super diversity means. It's one of these terms that you often hear in the newspapers. But basically, it means that if you look at classrooms nowadays, these are super diverse because of two evolutions. On the one hand, we've had global migration streams that are only increasing. So our learner audiences are more diverse in terms of background, in terms of mother tongues, and so forth. But super diversity also means that because we interact with other people through internet technology since the 90s, we are part of so many different communities, and we have so many different identities and so many different interests that a classroom is never the same as, let's say, a classroom in the beginning of the 90s when there weren't so many super diverse compositions of classrooms. So, for example, when you think about MOOCs, a piece of edtech, massive open online courses, which most of you will know, the classroom is also highly diverse. You have different mother tongues, different interests, different motivations, and so forth. And one of the issues with MOOCs nowadays is that there's a high dropout rate. Yeah, dropout is not only a concern of traditional education, but it's also a concern of online teaching, where you have basically super diverse audiences with different interests and who may not always connect to the topic at hand. So you need to find ways to deal with that super diversity and make edtech more personalized and adaptive. A second evolution that's happening in society at large, which makes that we need to step up our game in edtech, is the automation of human work through digital innovations. AI and so forth is having an impact already on the jobs of today, and our workers need to be rapidly reskilled. So a job that would, let's say, yesterday be carried out by someone, by a person, is now maybe partly automated, carried out by the bot or another kind of digital technology. So which makes that the jobs that we will do as we are today learners, of course, but in the future we are workers. Um, you will be confronted with more complex tasks because technology is sort of taking over in some aspects, but also more tasks that require advanced technological skills. So that's basically what we're seeing: more complex tasks and more tasks that require advanced technological skills. And these two global evolutions present a number of challenges for education and training that we tackle in our research. So we, on the one hand, we move from receptive and one size fits all learning, like MOOCs nowadays are mostly one size fits all. Everybody gets the same content. It's basically watching videos. Um, a little bit simplifying to to make it work, but basically it's receptive learning and one size fits all, toward more interactive and personalized learning. And often technology can help to go to more interactive and personalized learning, but often also technological research and innovation is needed to actually make that work with impact. Yeah, I've already talked about MOOCs, but you're looking here at a picture of another setting. This is a setting where an operator is being trained for doing more complex assembly tasks in the manufacturing industry. Manufacturing industry nowadays is confronted with an evolution from larger batches of one product to smaller batches of more diversified products. So more complex products, more customized products, because the customer experience or expects that. So this results in more complex work for the operators, but also more frequent retraining is needed to make in order to be able to make new products. And so the piece of edtech that you see here is a piece of what we call spatial augmented reality. So the operator is sitting at his usual workstation. He's sitting at a desk here, but there are video projections, a little bit small, but there's a projection. There's a projector here at the top of the screen that is projecting videos and other types of instructions to help this operator assemble the products more effectively and more efficiently. And this is an example of interactive and personalized learning on the job that would previously be done through a PowerPoint, for example, more receptively. And so the big advantage here is that operators can learn on the job while actually making the products. But the challenge here is that these technologies are not personalized yet. So every operator gets the same instruction, whereas some operators may be more advanced and may need less instructions and that kind of thing. So we're working on that in one of our research projects. Another challenge that we tackle in our research is moving from learning in one time and space to learning across spaces and times. Of course, when you record a Zoom webinar, you can watch it after it's taken place. So that's learning across times. But you also have learning across spaces, and that's what you see here. This is a project that we're doing with the Belgian Ministry of Defense, where some of their Marine Corps may be at sea for a longer time period and still need training. So, for example, they may be on a boat somewhere for 3 months, and the basic training is given, or the trainings that they need is given in a training room on the mainland. And so they were inspired by what you're seeing here is our hybrid virtual classroom. That's a piece of technology where both uh, the teacher is present in the main training room, and you can have physical students here sitting in this row, but you also have remote students who may be at a different space together or separately, and they are actually participating in the physical classroom, but they are visualized on screens. And there's all kinds of possibilities to make the learning experience interactive through polls and that kind of stuff, through audio and visual streaming bidirectionally. So you can actually, for both for the teacher, it feels as if the remote students are in the classroom itself, and also for the remote students, they indicate that they feel relatively, let's say, seamlessly involved in the experience, even if they are remote, for example, at sea. So this is a pilot project we're doing with them to find out what works best for their audiences. Other challenges, I think EdTech is perhaps best known for simple tasks, drill and kill, multiplication tables for maths and so forth. These are sometimes necessary for learning, but we also know that technology is necessary to support more complex learning tasks. For example, when you collaborate, and that's what you see on the next slide. Here we have a group of students, one of our engineering programs at the campus, who are assembling or building actually a self-driving car, which you see on the table here, and they are all present in the same location, but they all have a different role. So one student may be programming the robot, the other may be looking at the data that comes out of the sensors, the other may be looking up formulae on Wikipedia or other kinds of help information. So they each have a different role that works when you're doing collaborative learning. But we also have, and that's what we see in the back, and this is becoming more frequent, of course, in many settings, in this collaboration room, all students can connect wirelessly to a shared screen, and actually sharing those screens helps them to have a shared space and a joint focus. So this is a piece of technology that also works quite well, but which we are improving to make them collaborate more effectively. So all these challenges we are tackling in our research. And of course, in all of these settings, it's increasingly more easy nowadays to collect data about learning processes in unobtrusive ways. I think the best known example of that is interaction data. Whenever you click on a web page, whenever you type something, whenever you speak, that data can be recorded. And we can use these data to make the learning experience more personalized, adaptive, and also eventually more effective. That's the end goal of our research. And the main message here is that, or the key opportunity is that these data can now be collected unobtrusively, whereas earlier we had to do that manually with lots of annotations or observations, but we now can do that manually, automatically, and then actually also use that data in the system to deliver adaptivity in real time. So you have audiovisual data, but you also have eye tracking data, which is used in our more experimental contexts. But we also experiment with physiological sensors. IMEC has a state-of-the-art device for measuring stress, for example, on the basis of physiological data, and we are improving that technology together with our colleagues and engineers at IMEC to, for example, model stress and cognitive load in learning environments. And we also look towards mobile EEG, which Rudy may tell a little bit more about in his presentation later today. So our vision for educational technology tomorrow then, and what we are working on, is that basically the loop is closed. And so what you see here at the bottom of the screen is that the behavior or the learning processes of the students are tracked automatically. They end up in a database, often nowadays, of EdTech products, but often they are not made valuable or valorized or used in any way. So we develop techniques to extract information from that huge pile of data, to investigate learning processes, to design learning environments that are evidence-based, and to allow learners and teachers to make data-driven decisions on the basis of dashboards that can help teachers to make to have a better insight into the learning process, but also dashboards for students that get a better insight in the learning process at the same time. And so what all that leads to is personalization in tasks for complex learning, and that personalization can consist of, for example, content sequencing, where you order the tasks in the order which you think is more interesting or optimally challenging for learners. We offer learning support that is adaptive. So, for example, for a more advanced learner, you will show less instructions than for a more novice trainee or student. And then we also work on, for example, personalization in collaborative learning, because personalization and collaborative learning, that can also happen, for example, to form optimal teams. So, for example, when you do a complex collaborative task, it's good to have different roles and different expertises and disciplines together. So we're working on technologies that can actually recommend to teachers on how to best form their groups, for example, in a Zoom meeting when you're going to breakout rooms. That's the kind of basic research that we're doing. So that was what we do in terms of research, but how to actually bring that to innovation. That's not the same thing. That's an entirely different ballgame. And how do we do that at ITEC? What is our expertise and what is our valorization strategy? The first piece of expertise that we bring to the table is our team, which is, as I said, interdisciplinary. And when you look at the vision that we have on EdTech, our team is actually plotted on that. So we are a mix of people with backgrounds in educational sciences. That's the blue team here, who focus on instructional design for educational effectiveness, who do experimental research on the effectiveness of interventions in edtech environments. And then we have that's the green teams here. These are people with a more methodological background who work on statistical techniques to extract information from data, and they collaborate with people in machine learning, so with a background in computer science, and also with people in language technology. Whenever we have to deal with unstructured data, so textual data or speech in learning environments, then we have that team that comes to the front. And so, as you see in our team, we try to stimulate these interactions between the different disciplines, because these people are typically trained in different departments, are also linked in Leuven to different faculties and different departments. But at ITEC, we forge these connections between those disciplines. The second piece of let's say strategy that we have to make innovation work is that we have a state-of-the-art research infrastructure. And I've already shown that, for example, this hybrid virtual classroom that we see here, we share that with the partners that we work with. So, for example, the Belgian Ministry of Defense comes to our lab. So we basically take their setting and replicate that as a sort of digital twin, you could say, in our research lab. And this research infrastructure is a fully connected and award-winning learning space for synchronous hybrid learning. So our virtual classroom has won a prize last year from a European organization for most innovative hybrid classroom. And then we also have an extended reality lab where we experiment with virtual reality and augmented reality, and with more, let's say, sci-fi devices like eye tracking and EEG and so forth. And our researchers also run many of their experiments because they're working with big data on the cloud infrastructure that's available at the Flemish Supercomputing Center, which KU Leuven participates in. And so all of that is part of our EduLab, that's our research infrastructure. Third element, and that's a very important element to create innovation with impact, is we collaborate. We collaborate not only with other researchers, so whenever, for example, we need to tackle a challenging problem that involves computer vision, we don't have experts in computer vision in our team. We collaborate. We collaborate with groups at other university groups in Flanders, within IMEC, because IMEC is not only a research institute, but also a hub and an ecosystem that brings together research groups from the different Flemish universities. But we also collaborate with, and that's important when you try to bring research to innovation, we collaborate with edtech entrepreneurs and with innovative schools. And I think the people of UCL, University College London, have called this triangle the golden triangle, the triangle of researchers, edtech entrepreneurs, and educators. We add a fourth component to that. We work in a quadruple helix model where we have the government involved, not only as a sponsor or stakeholder, but also as an active partner in the innovation process. And that's actually key to bring innovations in education to society, because of course the government has a big stake in education for its entire population. And IMEC is positioned here on the slide, of course, because IMEC, as I said, is not only a research institution, but also a hub, an ecosystem that brings together all these different parties, and we're very happy to be part of that ecosystem in Flanders. So we have yeah, many different colors, of course, here, partnerships with the industry, EdTech companies, training institutions, educational publishers, and end users such as the manufacturing industry. Um, but also we collaborate, for example, with the media sector whenever we have a project on informal and non-formal learning. Um, we often collaborate with the media sector. Why do we collaborate with industry? Because they challenge us to work on real cases, to challenge our assumptions about what works in practice and what doesn't work in practice. And they actually also have the audience and the data, often messy data that we have to clean, but they will work with real data with us. Whereas in our lab, we often work with smaller data sets with let's say not always realistic data. So we need to have those collaborations with the industry to challenge our assumptions and to collect real data that helps to deliver technologies and innovations that will actually also work in the longer run in practice. And then the final model, which I would like to, or the final piece of our strategy that I would like to share with you today, is a business plan to enable research-based innovation. You don't do research-based innovation at the university lab, not alone. So we as innovators, some of you may be familiar with this model of the adoption of innovations by Rogers. So we as researchers are typically here, the tech enthusiasts and the innovators. But actually what we want to do is to make that research available to society and to scale it up through innovations to this entire chain. So also to involve the early adopters, the early majority of edtech users, the late majority, and also the laggards, the teachers that cannot be convinced and the learners that cannot be convinced to use edtech for their learning. And so where we are typically involved most heavily is in the beginning here and at the level of tech enthusiasm, and we are less and less involved whenever we go to what is known as the innovation chasm. This is where research and innovation often stops because we write papers and we deliver technologies, but it's not being picked up by society. And to actually bridge that gap between, let's say, tech enthusiasts and then the early majority, we have a business plan. We have a business plan together with IMEC in the Smart Education Research Program that Rudy will explain later today also. And that business plan is comprised of 4 layers that interact, but that also have their unique position in the business plan. So we have strategic basic research, long-term innovation that is driven by academic curiosity, where you have an idea that you, at the beginning, not even know whether it's feasible in practice. And then finally, you have what you where you want to go is to go to rollout of the technologies and the research into society. That's the furthest we go. So we don't go further than rollout. And rollout is at a higher technology readiness level, a higher maturity level of the technology that is actually closer to market, TRL 8, sometimes even 9. And we are involved in all of these, let's say, all of these um, collaboration models with the industry. So here we have collaborative research with the industry. Here we have collaborative development projects, for example, with early adopters, schools that would like to use a new piece of innovation or would like to develop that together with an edtech startup, and we coach those schools to carry out this project. But we are typically not really involved or not to a high extent in these projects, but we guide our partners to make the research innovations available and scale them up to society. So that's basically the full innovation funnel and instruments that we have available. So with that, I see that I've been talking for half an hour, which is I think my my allotted time slot. Wim?
Yes, that's indeed, Frederik. Thank you very much for this inspiring talk. I think we still have time for maybe a quick question. You ended with a nice cliffhanger for what Rudy is going to tell about what IMEC is doing. So maybe we should not go into that part yet and wait for Rudy to talk about what IMEC is doing. But whoever wants to ask a question about what Frederik just shared with us, the floor is yours. Milena, you want to ask something?
Yeah, actually, I wanted to ask because many of the solutions that that you were showing was also about well, the question that raised in my head was about security. So, for example, analyzing the stress level of the student, and so how does it work? I mean, I can't imagine myself wanting something like that in myself, but how does it work in a classroom? How does it work in terms of security?
That is a very good question, and a question that I would have to defer, I think, largely to one of the research groups that we collaborate with. We don't have experts in digital security and privacy in our team, but we do collaborate with different university departments in IMEC and at KU Leuven on that topic. It's a very challenging problem. So I think it's also something that Rudy may touch on in his presentation a little bit later on smart health, where you have the same actually challenge whenever you collect a piece of confidential information from an end user, be it blood samples that are digitized, or be it a piece of a part of the learning process that is being stored somewhere on a server in the cloud. You need to be sure, damn sure, that you deal with privacy and security in a good way. And so one of the departments that we collaborate with at IMEC is developing, or different departments actually at IMEC are developing techniques to both preserve the security and also the privacy of of end users, learners in our example. For example, by keeping the data close to them, so rather than storing them on a cloud infrastructure, each learner or end user has some kind of, you could call it a data bucket that they choose to share with a certain party or choose not to share on the basis of an agreement. But the key thing is that here that the data resides with the end user and not with the company that then can do all sorts of creepy things with that.
But end user meaning in that sense, for example, the student or
student, the learner, or the teacher. Yes.
Okay.
Exactly.
Right.
Mhm.
Yeah, I'm still wondering how much as a student I would like my teacher to know that my teacher stresses me out, for example. But I guess that's less of a privacy discussion and more of ethics.
Yeah.
That's another
Thank you.
problem.
Yeah.
Exactly.
But we can come back to that the last day, Milena, when we talk about the more philosophical aspects and why innovation and what kind of values do we cherish. I've seen two more questions. Maybe one, Chelu, you wanted to ask a question. You raised your hand.
Thank you very much. So thank you for the talk. There are a lot of questions that are raised to me, but I would like to focus on just one. So looking to the slide where you were talking about the interdisciplinary teams, that there are like different people working in this project. I would love to know how many people from your university, Frederik, works in each of the projects. How much time does it take usually to manage that project from the inception to the rollout?
How much time or how many people?
Both.
Both. Yeah. It depends on the project, really. We have PhD students who work relatively on their own for 4 years on a very challenging, for example, challenge in developing a new machine learning algorithm. And then we have PhD students who work on multiple projects with the industry from the start of their employment in our research group. And some of these projects can take 2 years, others can take 4 years. It really depends on the challenge that you want to tackle, and also on the innovation horizon. So for example, if you're working, and to be specific to, if you're working on the lower technology readiness levels, let's say technology readiness level 2, 3, and even 1, which is where our basic research fundamental PhD research happens, it takes longer. The ideas are more challenging, it takes more time. But also there, I think it's crucial to say that in order to make the innovations come from research to practice, these research collaborators already work with the industry. Because as I said, it's important that we challenge our assumptions about what works in practice and what doesn't work in practice. So to come back to the question of Milena about privacy, if someone is developing a new algorithm to extract stress in learning environments from a big pile of data, but it doesn't work in practice because the educators don't want it, or because it's not useful, or because it's not implemented in a way that suits them, then the innovation will fail. It will end up somewhere in a file drawer, in the best possible worlds in a PhD dissertation, but it will not go through it will not seep through to rollout phase, to actual use in society. So I think my main message of today is our researchers are involved in innovation projects and collaborating with industry from the very start of their work.
Okay.
Does that answer your question a little bit?
Yeah, I was thinking also if there are people also from the university managing the projects, or all the workload relies on the PhD, and they take like the full project and they manage on their own. And they, because they have to collect information from instance from the student, from other teacher, they have to create scenarios to work with them. Probably they don't have like the resources or the contacts to do them by themselves.
All of our people work in a team. So PhD students are primarily supervised by their by a principal investigator, that's a professor in the university, but they always collaborate in a team. There's no point in having a research group if these people don't interact and learn from each other, and learn from interacting with other research groups and industrial partners and society. So they all work in a team.
Thank you.